Good evening, this is Mr. Wintermelon, and this is sort of a bonus video where I will show you the size of a few different molecules. It is good to know the size of different molecules as it gives you a reference as to what kind of molecules can pass through a cell membrane as well as a whisking tubing. But for cell membrane, it's more or less controlled by the channel that are embedded in the membrane. But whisking tubing doesn't discriminate besides size. So what I have down here are some water molecules. It's probably one of the most iconic molecules around because first, it looks like Mickey Mouse. And the chemical formula is very simple, H2O. H meaning it has two hydrogen down here and one oxygen molecules below, or it can be on top. But whatever the case is, water molecules, right, it is partially charged. What do I mean? So over here we have oxygen, and because the oxygen contains a lot more proton than the small hydrogen, which only contains one proton, it will sort of draw the electron towards it. So the one electron of hydrogen will be down here. So over at this side, the hydrogen will be partially positively charged, while over here there is two pairs of electrons, and over here the water molecules will be slightly negatively charged. So if I were to arrange the water molecules, right, it will be something like that. The partially positively charged hydrogen will be attracted to the partially negatively charged oxygen of another water molecules, while the partially charged hydrogen molecules will be attracted to the partial negatively charged oxygen molecules of the water. So this is the size of water molecules, H2O. Next, I have these molecules that looks like a phallic symbol, a penis. So this is actually the urea, something that does come out from a penis. And you can see that the size is larger than the water molecules. So both of these can pass through and be filtered out in the kidney. Next, some larger molecules I have with me down here. Okay, let me take the water molecules off so that it is more tidy. So you can make a smart guess what is these molecules. The black color molecules is the carbon molecules. So I have 1, 2, 3, 4, 5, 6. 6 carbon molecules. So what molecules have 6 carbon molecules? And how many oxygen molecules? 1, 2, 3, 4, 5, 6. So the molecular formula for these molecules is C6, H12, and O6 is the all-important glucose molecules. So the size of glucose molecules is, this size, and it can pass through the cell membrane. Finally, I managed to fix up this disaccharide. So you can compare the difference between a water molecules down here and the size of a disaccharide, specifically sucrose. So for sucrose, right, it cannot pass through a cell membrane. But a glucose, which is about half the size, can pass through a cell membrane. But if you ask me, it got more to do with the protein channel which allow glucose to pass through, but there's no protein channel which allows sucrose to pass through. But fun fact, for your Cambridge exam, your O-level, they take it as disaccharides such as sucrose can pass through a whisking tubing. While sucrose cannot pass through a living cell membrane, it can pass through a whisking tubing, according to Cambridge. So my suggestion is you take it as, for whisking tubing, monosaccharide and disaccharide, they can pass through, but your macromolecules such as your starch, it cannot pass through. On the other hand, for living cell membrane, monosaccharide, glucose, galactose, fructose can pass through, but your disaccharide, such as your maltose and your lactose, as well as sucrose, they cannot pass through a cell membrane.